Hello and welcome again to yet another session where we'll be talking about or we'll be dealing with problem that has to do with mathematics. Today's topic we have to do with a very fundamental topic or a subject in mathematics, ratio and proportion. Ratio and proportion. Let's delve into it. Today, in our topic or discuss today, we'll be talking about the meaning of ratio and proportion. We'll be talking about the types of proportion. Talking about the three types stated in your screen right now. We'll be talking about the formulas and properties of proportions. We'll be talking about difference between ratio and proportion. And then we'll be summarizing our work with some examples. Also, we'll be looking at the exam guide. Let's begin. What ratio and proportion are explained majorly based on fractions. So the presence of fraction, which we have done in earlier or previous classes, sessions, will come to bear in this particular topic because ratio and proportion has to do with fraction. Now in this form, in the form when it is a ratio or it is proportion, it deals with the presentation of A colon B. What I mean by A colon B? It deals with the form of A colon B, which is today's date is 05/09/23, which is A is to B. Now, as we go further, we will find the meaning of the colon you're seeing on your screen. It is a ratio, whereas proportion states that, or proportion is describing the relationship between two ratios. It's checking if they are equal or not. It's checking if they are equal or not. Here, A and B are two integers. So A and B are integers. Integers are whole numbers. A is a whole number. B is a whole number. They are separated by the colon. The ratio and proportion are the two important concepts, and it is the foundation to understand the various concepts in mathematics as well as in science. Like I said, it is a fundamental subject or topic when it comes to the work of mathematics or mathematical problems, because almost everything you do, you must be able to relate one or two things together, and that's where proportion comes in. As we go further, you will see the definition and the description of both ratio and proportion. For example, 4/5 is a ratio and the proportion statement is 20/25. Means you have to balance it, or you use 20/25 equal to 4/5. May I also add here at this point and tell you that for you to work with ratio and proportion very well, or rather in proportion, they deal with more of equivalent fraction. Remember when we did equivalent fraction? They are the rising power of each fraction. For example, 1/2 is similar to 2/4. Also similar to 3/6. So while the top is increasing by 1, the bottom part is increasing by 2, because we have 1 here and we have 2. So the more you increase this one by 2 and increase this one by 1, the more you keep having an equivalent fraction. So if you look carefully, the equivalent fraction of 4/5 is similar to 20/25. But that's not what we're talking about. We're not talking about equivalent fraction today. We're talking about proportion. So what if you have a case when you have 20/25 is equal to 4/5? Now this is a representation or a proportional statement. It tells you you are trying to compare or try to relate two ratios, 20/25 and then 4/5. Like I said, when there is a comparison between two ratios or relationship between two different ratios, we are talking about proportion. Ratio in itself is just one of these. One of these now, like this, is a ratio. But when there are two of them, we're dealing with proportion. Therefore, the ratio defines the relationship between two quantities, such as A and B. The two quantities are known as integers, as we earlier stated. Where B is not equal to 0, example, the ratio of 2 to 4 is represented as 2:4, which is equal to 1/2, which we have earlier stated that is in this form. It's in this form, as we will see later. And that statement is said to be in proportion here when you compare two equivalent fractions or two fractions at a time. We're talking about proportion. Now let's see the definitions. Finally, we're here. Ratio. In certain ratio meaning, in certain situations, the comparison of two quantities by method of division is very efficient. We can say that the comparison or simplified form of two quantities of the same kind is referred to as ratio. Just forget about the long statement and the semantics here. Just focus on when they say two quantities, we're talking about 2, for example, or 20, let's use this case, and 25. One quantity, two quantity. The comparison between both of them is what formulates ratio. And ratio is represented by this sign. So what you're having here, this divisive sign that is here, which is division, is this sign that is here. Now, ratio is, as we'll see later again, is otherwise known by different names, which are related to the division names. Because the division has out of, is to, or into, or over. Ratio is related to those names too. In this case, this is represented or referred to as is to. So our answer here will be 20 in ratio 20 is to 25. This is the same thing as this over here. Let's move on. Proportion. Definition of proportion. The proportion is an equation that defines that the two given ratios are equivalent. The word equivalent there means equal to. So just know about that. Equal to is the word equivalent. Means they are equal in size and in a proportion. Are equivalent to each other. In other words, the proportion states that the equality of the two fractions or the ratios. I'll tell that one more time. The proportion states the equality of the two fractions or the two ratios, or the ratios rather. In proportion, if two sets of given numbers are increasing or decreasing in the same ratio, then the ratios are said to be directly proportional to each other. I repeat that again. If two numbers of the same quantities, or rather the same strength, are being increased in the same like manners, like this, they are increasing at an equivalent ratio, equivalent rate. It then means that ratio is said to be direct proportional or directly proportional to each other, as we're going to see when we get to the types of proportion. Now, like I said earlier on, this sign, it's what denotes the ratio, is the symbol that denotes a ratio. That's the sign, or the sign that denotes a ratio. A ratio can be written as a fraction, say 2/5. We happen to see various comparisons or say ratios in our daily life. It is everywhere around us because we always want to take a fraction. As long as you're dealing with fraction, you're inevitably dealing with ratio. And as long as you're comparing two particular fractions, you're inevitably also comparing or dealing with the problem of proportion whenever there are two ratios or fractions being compared. Hence, the ratio can be represented in three different forms, such as A to B, A is to B, and A divided by B. These three comparisons makes up all that ratio is all about. A to B is the same as A is to B, and also the same as A over B. As I said earlier on, they all carry up the names or the forms that are used in fractions or fractionable problems. Now, key points to remember when you're dealing with ratio. Ratio should exist between the quantities of the same kind. There must be ratio. Number one. Number two, while comparing two things, the units should be similar. While comparing two things, the units should be similar. What do they mean? By that we mean that, say I'm comparing 1 kg to be shared at 200 grams. I'm comparing two things right now. This 1 kg is in kilograms. The 200 is in grams. If I attempt to do this in this way, I will have a problem. I will come close to a problem or a fault. What do? I must ensure that both units, that's what I'm looking for, both units are the same. Now, it's either I'm changing the grams to kilogram or I'm changing the kilograms to gram. What do I mean? 1 kilogram, we know that 1,000 grams makes 1 kilogram. Therefore, I will use 1,000 grams instead of the kilogram as against 200 grams. This is a ratio. Similarly, I can use 1 kilogram, and because I know 1,000 grams makes a kilogram, but in this case we have 200 grams, means we have a fraction. It's not up to the 1,000 yet. So I will have, if I do 200 divided by 1,000, I will have 2 over 10. And if I cancel this, I will have, if you remember when we did our conversion from fraction to decimal, and we talked about the fine numbers that end with 0, very easy to work with. In this case, we have 2 over 10. It's very easy to work with. So we just divide the 0 at the end and move a 0 in front of a 0 and a decimal point in front of the 2. Thus, we have 0.2. That means this place we have 0.2 grams, or rather kilogram. Kilogram. Now, in this case, I made the both units to become grams. In this case, the both units are kilograms. You must always balance it before you go further. There should be significant order. There should be a significant order of the terms. The rising should be significant, whilst it is equivalent. It should be significant. Means there should be no insignificant order in it. Zeros and the rest. The comparison of two ratios can be performed if the ratios are equivalent like the fractions. Note, proportions all are denoted by the symbol this, which is double colon, or the equal to sign, which denotes equality. Because what is good for the goose, in this case, must be good for the gander. What is at the left-hand side must be equal to what is at the right-hand side. Now we have gotten to types of fractions. Proportion can be classified under 3 categories, which are direct proportion. Number 1 type is direct proportion. Now I will show you a description of a direct proportion in a way. So we'll just rush through this part very fast because I've explained in at some length what direct proportion is all about. So in direct proportion, we have, for example, you have A over B equal to C over D. This is a direct proportion, where all the alphabet, the given alphabet, the A, the B, the C, the D, all are integers. Now, what do we say? The direct proportion describes the relationship between two quantities in which the increase in one unit, in one quantity, there is an increase in the other quantity also. So an increase in one quantity will lead to an increase in the other quantity also. What we mean is an increase in 1 over 2, 1 will increase to 2, means this one will also increase back to 4. It will be increasing by 2. This is you comparing two different ratios. The other quantity, okay, similarly, if one quantity decreases, the other quantity also decreases. Hence, if A and B are two quantities, then the direct proportion is written as A. The symbol you're seeing there is infinity B, or A relatable to B. Let's leave the long statement there. Let's focus here for a moment. Let's get some ideas of what we are trying to talk about. Now, we did initially 20 over 25 equal to 4 over 5. And we know that this is a direct proportion. So what are they saying here? You will cross multiply. The lower part at the left-hand side will meet the upper part at the right-hand side. The denominator at the right-hand side will meet the numerator at the left-hand side. And then you have a definite answer. And like I said before, what is good for the for the goose is good for the gander. So what is good over at the left-hand side? Left-hand side must be equal to right-hand side, as we will see. So you have 25 times 4. We know that 25 times 5 is 100. 20 times 5 is 100. 25 times 4 also 100. Now right-hand side and left-hand side are both equal. In this case, it's a direct proportion. That's for number one. Now we have the next one that is known as the inverse proportion. It is reflective of something opposite the direct. In inverse proportion, it will be in the case of when we did our decimal, when we did our division of fraction, converting our division of fractions to multiplication, we know that we usually change position. In this case, it's similar to that. The inverse proportion describes the relationship between two quantities, in which an increase in one quantity leads to the decrease in the other quantity. In the other case, increase in one quantity leads to an increase in the other quantity. But in this case, increase in one quantity will lead to a decrease in the other quantity, and a decrease in one quantity will lead to an increase in the other quantity. Therefore, the inverse proportion of two quantities, say A and B, is represented as A infinity 1, or rather A alpha, A times 1 over B. A times 1 over B, please. That's not alpha, please. That's times, please. Now, let's leave the long description that is given there, focus on the board, and see what they mean. When you have A over B is equal to, now in this case, there's two ways you write it. One is this way, C over D raised to power minus 1. The presence of minus 1 tells you it's an inverse proportion. Why is it an inverse proportion? Now look at the next part. Let me just cite it again, the same thing, and show you what is happening. This 1 raised to power minus 1, the presence of minus gives you or denotes a division. A division. And the presence of 1 means the 1 is upward. So you're having 1 divided by this whole quantity, quantity here, which is C over D. So having 1 divided by C over D. Now let's leave this part for a moment and focus on this other area, the right-hand side. This is the same thing as what we just wrote here. You will see a trick. Initially, when we did the direct proportion, the answer was basically, apart from this one here, the answer was just A over B equal to C over D, but you see a difference now. Now, the presence of this one means I have to put 1 again. If I change the times of the sign of division to multiplication, in order to solve my problem, I will have times, my D, change of position comes in. D will go up, C will come down. So D over C. 1 times D is D. So we have D over C. I'm putting it back here. we have A over B equal to D over C. Now there's a change. Our good friend over here, the quantities over here, the B, C and D have changed position. That is the difference between direct and inverse. Inverse means there is a difference in the positioning of the quantities, of one of the quantities at and a particular segment or area. So this is our inverse proportion. So do you want to leave it as 1 over C over D? It's a choice. But inverse is so tricky that if you don't pay attention to the movements, you may fail it. Let me give you a simple or a simpler way of doing it. If you are given a question like this, 1 over 2 equal to 4 over 5, and they put it like this, inverse, or they put it 1 over, they put it this way, 1 over 2 equal to 1 over 4 over 5. When it's an inverse question, or they ask you to find the inverse, as long as there's inverse there, the simpler way of doing it, just imagine, just put back this good friend here, 1 over 2, change the position of the other one. That's the answer. That's your work. Equal to 5 over 4. Now I've done the inverse. Don't make the mistake of going through a long process. You might fall into a trap and you just fail it. You just might fail it. Just imagine it, reason it, change the positioning, and you're good to go. In this case, after you finish changing the positioning, you just cross multiply and you start to do your work. Now we have the one we call, this one doesn't apply that much because we don't see that much, but it's also part of the proportion. It's kind of a recurring proportion. It's called the continued proportion. Consider two ratios to be A is to B and C is to D. Then in order to find the continued proportion for the two given ratio terms, we convert the means to a single term number. What it means is just to do your LCM. What you usually do when you do your fraction. So a single term reason. Thus, first multiplying the first ratio of C and the second ratio of B. Okay, sorry, for the given ratio, the LCM of B and C, which are the top down. You're taking the top down means you're taking C and D because it is A over B equal to C over D. You're taking this one and this one. And then you're taking this one and this one. So, sorry, this is B. Let me put it well. So the LCM of B and C, you look for that first. So thus multiplying the first ratio by C and the second ratio by B, we have first ratio to be CA, second ratio to be CB, or rather BC. So the first ratio, this one, A over B times B, A over B times the LCM between both of them will be CB or BC equal to C over D bracket BC. In this case, B we cancel B and you have AC is to C we cancel. Sorry, let me come again. C we cancel C. Okay, the inverse. Okay, C we cancel C will give us BD. First multiplying the first ratio by C and then the second ratio by B, we have the first ratio to be C is to A, CA is to BC, second ratio to be BC, BC is to BD. Thus, the continued proportion can be written in the form of 3. CA is to BC is to BD. So that's all about the ratio, the types of ratio. Now we have the ratio and proportion formula. The ratio and proportion formula. We already come through what the formula is all about. The relationship between A. I will not waste time on this because we have touched this when we were dealing with the definition. Talk about the symbol or the sign, which is the colon sign symbol that is used to differentiate the two relationship, which is the two quantity, which is A and B. So the main formula for ratio is just this. Why the main formula for proportion is this. As good as this. A is to B means the division, but A is to D means equality. It means equality. So we can expand. This is the relationship between two quantities or two different quantities. For example, you're giving A is to B is to C is to D, means you're doing, since we know this one is the equality sign, you're doing, and this is the division sign. We're doing A over B equal to C over D. That's a simple description of the formula for proportion. Important properties of proportion. The following are important properties. Now, these are quite complex for you, probably for you to understand, but just follow the footstep, go through these notes, go through it over and over again to understand the process. Forget about the names if that's too hard, but if you look carefully about the names, they are names that can be related to English, the English word. For example, we have the addendo. Why that's a foreign name or a Latin name, addendo also means addition. Now, if A is to B equal to C is to D, the relationship is now A plus C. You're taking both of them aside. A plus C is divided by B plus C. B plus D rather. Now that's the additional rule for, or additional property for proportion. A is to B. A is to B equal to C is to D, which you know the fraction method of showing it or the division method of showing it. Now they say this relationship is now, this will come to be this one, plus C is equal to, this will go to be this one. B plus D. That's the relationship for the addition property. Now we have the one, next one is subtraction, basically subtraction, called subtrahendo. Now it's the same method, but in this case, there's a, instead of the addition, is a subtraction. The next one, similar method, but in this case, you're using the relative part of each to go against each other. What do I mean? It's called dividendo. You're having a relationship between the same thing, A, B equal to C, D. This is A minus B. You use the last one to become the divisive word. It's similar to how we look for LCM when we are doing fraction, addition of fraction. But in this case, that's what they meant by A minus B is to B rather. Now this is also equal to same thing, similar, minus D, the person at the end will be one you use to divide. This is the relationship for the dividendo. So we also have the componendo, which is all about the components of the compound or the relative compound of each ratios or the proportions of the ratios. So in this case, initially we use a negative, but in dividendo. But when you come to componendo, you are using addition. Addition is same method, similar method. A plus B all over B equal to C plus D all over D. Is a relative way by which was derived that the dividendo, instead of using, probably you might be expecting a multiplicando, something like that, they use a component because it's still relative. They are relating two different quantities together. Hence, it is important that the components should be divided by the denominator there that is representing in that particular that's a ratio rather. Now we also have the alternando. Now the alternando is simply changing positions. That's what it's all about. What it means is you have A is to B equal to C is to D. Change your positions. This one will come to me this one because when you do it, what's alternando? Alternando actually is the real description for the real proportion. What I mean is this. So we have a over B equal to C over D. Now, what it means, this one is coming to me this one, and this one is going to me this one. Hence, it is A is to C equal to B is to D. Then we also have the invertendo. Now, the word there is just there. Invert, inverter, inverse. That's what we're talking about. You're doing why you're doing alternative for this one to use the alternative of this one for this one. Now this time you're using their inverts against each other. What do we mean? The B becomes stop, the A becomes the B becomes the supreme word there, the supreme work there, or we want to call it like the normal fraction term, the numerator. And the A becomes the sub term there, or sub work there, or we call it denominator. So they change their position from the natural level, the natural state. They change position from the natural state. It changes and it becomes B is to D, A equal to D is to C. Change of positions. That's what invertendo is. Now they ask you, they can just play with your mind and bring in the component and the dividend together. They bring in the componendo and the dividendo as one to relate and balance it. Now you knew or you know what you did earlier on when you had the dividendo. You did a minus B, this time only for the division of the, you use A minus B divided by B, then you have C minus D equal to C minus D divided by D. Now in this case, you're relating both of them, means you're doing A plus B all over A minus D. Componendo, dividendo together. Divided by, you're still dividing again. Alright? Okay, you're equating it to C and D, which is now C plus D all over C minus D. You're relating the both compounds together. This is like a compounding property of a proportion. You compound two particular given problem together to make a particular or one whole problem to deal with. Difference between ratio and proportion. Ratio is to compare the size of two things with the same unit. Proportion is used to express the relation of two ratios rather. Ratio it's used to express it is expressed using a colon or a slash. The slash there denotes division. Whilst proportion is denoted or is expressed using a double colon or equal to. In terms of how they appear, ratio appears as an expression, while proportion appears as an equation, because by the time you cross multiply and do all your stuff and get things like this, it seems like an equation you have to deal with. Keyword to identify ratio is a problem. In a problem is to every there in quotes, to every. Keyword to identify ratio in a problem is to every. Whilst keyword to identify proportion in a problem is out of. Now there are some examples here, very simple examples. They are given two numbers in a ratio of 3:2. The sum of the numbers is 63. They say find the numbers. The first work to do there is to add the term. Remember, add the terms to make sure that you have their total, their totality, because it is each going against the totality, and then with the sum of each, that you can find what is allocated to each number. For example, you ask 3 is to 4, means you just do 3 plus 4, and the totality, the total of both of them is 7. But we know there's a number, there's a sum total. So this 7 is representing the sum total of 63. We know the sum number is 63. The 7 is representing it. So you're trying to find the ratio or the shared portion for each of them. How much out of this 63 is shared for each person? Each number rather. The first number is 3, so you use 3 all over the total times the shared portion. 3 over the total times the total number you are sharing. So 7 here will give you 1, and 7 here will give you 9. 3 times 9 will give you 27. So this man, out of the 63, he has 27. Why the second number? So second number, have 4 over 7 times 63. Again, similarly, 7 here is 1, 7 here is 9. 4 times 9 will give you 36. That means the second person has 36 as his shared value. Now, if you add the sum of the first and the second numbers, will give you the sum total of the number, which is 63. Similar to how you had 3, the sum of these two gives you the total portion, the total rates you're using. Similar to the sum of these two numbers will give you the sum total of the numbers that you initially shared for them. And 27 plus 6 will give you 63. All right, let's see another example right now. Say you're given two relationships. Let's say they say 4x is to 5 is equal to 3 is to let's say 2x. Now in this you're given two different ratios. You balance it up. 4x over 5 is equal to 3 over 2x. If you look closely, you will have a proper balance in this problem. Oh, sorry, please. 2x rather is to 3. So 2x is to 3. You have a proper balance now. You cross multiply. Now you know that this is a direct proportion. When you cross multiply, you have 4x. 3 times 4x is equal to 5 times 2x. And here we have 12x is equal to 10x. Now we can look for the value, rather the relationship of these two with their values to get x. If you look very carefully, the two sides have x. That means we're going to take them one side and it's imbalanced. Therefore, this ratio or this proportion rather is not balanced, because we said left hand side must be equal to right hand side. This is not an equivalent fraction or rather an equivalent proportion of problem. This is a faulty problem. It then means we have to work on this right hand side and see if we can work a different way. Now let's use 2 is to 3. Now you have 4x over 5 is equal to 2 over 3. In this case, we must have the answer for x. You cross multiply now, we will be having 4x times is equal to 2 bracket 5. You're having 12 s is equal to 10 and x equal to 10 over 12. Okay, 10 over 12. Now we will be having 2 into 10 will be 5. 2 into 12 will be 6. So let me write it over here. S equal to 5 over 6. Now you can either leave your answer this way, Or better yet, you can break it down to decimal. But let's leave it this way. And let's substitute the value of S back into this question to find out if this part, if this relationship, if this one, back into this equation, to find out if this is indeed equal to this. You have 4x. Let's represent x. Represents x with 5 over 6. So wherever you see x, you put 5 over 6. You have 4 all over 5 brackets 5 over 6 is equal to 2 over 3. So we've represented x, 4 over 5x, as 5 over 6. We can now divide. If you look very carefully, the bracket here indicates there's a multiplication existing between both problems. So we divide this quantity with this quantity, I will get 1, 1. Now we have 4 over 6 equal to 2 over 3. In this case, you can naturally see that it is equal. Because if I want to reduce down to the lowest, 2 into 4 will be 2, 2 into 6 will be 3. Thus, 2 over 3 is equal to 2 over 3. And this makes it an equal or equivalent fraction. Thus, this is a direct proportion and an accurate proportion. Unlike this one where we have two different properties that were not related. This is a direct proportion. Now let's get some exercise as we go home to do. Now we are having some exercise on our board. We are asked to, what was added to each term of the ratio 2:3 so that it may become equal to 4:5. Now it's just a progressive movement. What you add to the numerator and add to the denominator to give you 4 over 5. That is your equivalent fraction to 4 over 5. Then you can also do the relationship of sharing. The length of the ribbon was originally 30 centimeters. It was reduced in the ratio of 5:3. What is its length? Now, we did use the method of adding and then dividing to find the length, the reduced length. Then they say mother divided money amongst 3 sons or 3 children, Ron, Sam, and Maria, in the ratio of 2:3 and 3:5. 2:3:5. If Maria got 150, find the total amount and the money gotten by, or rather received by Ron and Sam. So we are looking for here for the money received by Ron and Sam. Just attempt these questions at home. I know I really did do any example on when you have a 3 quantity, you're having a ratio. You're trying to share share something or a bigger package for 3 persons or 3 quantity, 2 elements. That is in case of 2:3:5. But don't worry, it's just a similar method. You add all numbers, you add it, you use each number to divide the total number against the figure. In this case, Maria is the person you use against the other 2 to help you find the total amount received by the other 2. Because Maria has her proportion, or rather her ratio, and she also have the required amount. But the other 2 have their ratios, but they don't have the required amount. So use Maria as a guiding step to find the amount for both Ron and Sam. Now let's get some question from our exam guide. Now from our exam guide, all right, let's look for some question from our exam guide. And then 2 and 5, a question was asked. 3 brothers that shared the sum of 1,000. Let me write out the figures out. So 2 and 5, you asked question number 25. 3 brothers were shared 1,000. So total sum 1,260 naira in a ratio. So in the proportion of, in the ratio of 1:2:4. They say find the sum of money each received. So we know there are 3 brothers. So what do we do first? The first thing we usually do is to add. You add the ratio to get the sum total of the ratios. So 4, okay, equal to 7. So we find for each person, going it one by one, one after the other. So we look for 1. 1 over 7 times the sum total, 1,260 naira. 7 divided by 1,260 naira will be, 7 here will be 1, remaining 5. 7 into 56, is that 8? And then 0. Okay, so it's the first person got the sum of 1 times 80 is 180 naira. The second person got 2 shares, so 2 over 7 times 1,260. Again, similarly, the second person got, so here we get 180. 180 times 2 will give us the total of the second person, which is 360 shares, 180 shares, naira share, 360 naira share. And the third person we told was 4. 4 over 7 times 1,260 naira. 7 here 1, 7 here again 180. Now 4 times 180 will give us 0, 2, that's 720. Okay, 720 naira as his share. So we have the different value given, or the different amount found for each person. Now the sum total of all the shares will give you, or will show you how the total number, or give you the total number. 720 plus 180 will give you 900. 900 plus 360 will give you 1,260 naira. And your answer for that year will be option D, which is 180 naira, 360 naira, and 720 naira. So I hope you've enjoyed today's class, today's session. I will be seeing you next week. Keep doing your assignments. Keep working on ratios and proportions. Ensure you compare numbers correctly as relative in size or in their rates they're giving to you. And also go through the exercises and get it done in time. See you later and have a wonderful day.